Hello. Known as electrochemical series. So we have learned that, or we know that in the case of cathode, what takes place in the case of cathode? Reduction takes place, and in the case of anode, oxidation takes place. Now, in the case of cathode, or where the reduction takes place, the metal which undergoes reduction will have a higher value for standard reduction potential, and the metal where, or the element where oxidation takes place, it will have a lower value for standard reduction potential. Or in other words, we can say that the one which is having a lower value for standard reduction potential means the standard oxidation potential will be higher. If a metal or an element is having a lower standard reduction potential, that means the standard oxidation potential will be higher for such metals or elements. So based on these points, let us consider the electrochemical series. So here you can see the electrochemical series where the elements or the metals are arranged in the order of the increasing value of standard reduction potential. So in the top there is lithium, which is having a standard reduction potential of minus 3.05, which is having the smallest reduction potential. But what I have told you, but it is having the highest oxidation potential. So this table is arranged on the basis of increasing reduction potential. You can see that finally we have fluorine. We know that fluorine gets easily reduced. So in the case of fluorine, it is having an E0 value of 2.87, that is, it is having the highest reduction potential. So here you can see I have not considered all the elements, but I have just taken few of them from the electrochemical series. So as discussed, the lithium is having the lowest what standard reduction potential, but it is having the highest standard oxidation potential. And the below one, fluorine is having the highest standard reduction potential. Now how we have calculated this standard reduction potential? It is calculated with reference to the She electrode. We have already studied Edana She electrode. It is the standard hydrogen electrode with a value of 0.0 volt. Next we have to see what are the application of the electrochemical series. The first application of electrochemical series is to compare the relative oxidizing and reducing power. We have seen the positive sign of the reduction potential represent greater reduction potential. The positive sign, as it increases, it represents the greater reduction potential, and if it is having greater reduction potential, we can say that it is the stronger what agent? It is the stronger oxidizing agent. Greater reduction potential means stronger oxidizing agent. So you can see that our in this series, which is the strongest oxidizing agent or the strongest reduction potential, which one is having? Fluorine is having the strongest reduction, is the strongest oxidizing agent, or it is the having the highest reduction potential. And which one is the weakest oxidizing agent? The lowest value. Which one is having the weakest oxidizing agent? Strongest oxidization agent is fluorine, and the weakest oxidizing agent is lithium. So we can compare the relative oxidizing and reducing property of the metal based on the electrochemical series. Our next application is to compare the activity of the metal. So let us just see this electrochemical series. Here you can see that those metals which are lying above standard hydrogen electrode, and there are some metals which are lying below the sheet. So when hydrogen is taken as the cathode, the elements which are, or the metals which are lying above it, act as the anode. If hydrogen is taken as the cathode, then the elements lying above it in the electrochemical series act as the anode, and thus they undergo oxidation. And if Vice versa. The standard hydrogen electrode is taken as the anode, then the elements lying below it, that is the ones which are having standard reduction potential higher, will be behaving as the cathode. So we can say that in this electrochemical series, the greater the oxidation potential of a metal, more easily it can lose electron. What can we say? Greater the oxidation potential, that means it can easily lose electrons, and thus it will be having a high reactivity. That means greater the oxidation potential, it will be having a higher reactivity. That means what? Here you can see that lithium, sodium, then barium, calcium, sodium are there. So lithium, potassium, magnesium, all these are having a higher oxidation potential. So they will be having a higher reactivity compared to the other metals. So there is a question in your NCERT text. Can you store copper sulfite in a zinc pot? Just consider our electrochemical series. Just now what we have said, the elements which have a greater oxidation potential can easily lose electrons, and thus they have a higher or they have a greater reactivity. So the metals with greater oxidation potential can displace metals with lower oxidation potential. Is it clear? So in this case, we are asked whether we can keep copper sulfide solution in zinc pot. You can see that zinc is having a higher oxidation potential compared to copper. So zinc can easily displace copper from copper sulfate solution. So what will be our answer for this question? Can you store copper in a zinc pot? We cannot store copper sulfate in a zinc pot. Answer is no. And the reason is what? Because zinc is having a higher oxidation potential. So what happens when it is having a higher oxidation potential? Since it is having a higher oxidation potential, it is highly reactive. And what happens if it is highly reactive? It can easily undergo oxidation and displace the other metal. So our next application is to calculate the standard EMF of any electrochemical cell, that we have already discussed. How we are writing the standard electrochemical cell? We are writing it as the one which is having a higher reduction potential minus one which is having a lower reduction potential. Or we can further write it as the one which is the cathode, where the standard reduction potential is higher, and the one which is the anode, where the standard reduction potential is lower. So these three are the main applications of electrochemical cell. Apart from that three applications, we can also find another application for the electrochemical series. That is, based on the electrochemical series, we can predict whether a metal reacts with acid to give hydrogen gas. How can we say that? We can see the metals which are having a higher oxidation potential have a greater tendency to lose electrons. So we can say that all the metals lying above hydrogen, that is the ones which are having lower reduction potential. So all the metals lying above the hydrogen in the electrochemical series react with acid to give which gas? To give hydrogen gas. And lower the reduction potential, higher is the reactivity, that we have already discussed. So all the elements lying above hydrogen in the electrochemical series easily react with acid to give hydrogen gas. And let us consider the last application of electrochemical series that we are going to discuss, that is to predict the spontaneity of a redox reaction. We can say that for a redox reaction to be spontaneous, the EMF should come out to be positive. The EMF of the cell, the EMF of the cell should be positive for a redox reaction to be what? For a redox reaction to be spontaneous, the EMF of the cell should be what? It should be positive. Now, if the EMF comes out to be negative, that means the direct reaction cannot take place, but what? But the reverse reaction may take place. So I hope the electrochemical series and the applications for electrochemical series are clear. Hope to see you soon with our next video.